Hey everyone, my name is Paweł and welcome to the talk about how to design a good API, what to look into in specific. So, few words about me. I'm a programmer since more or less 9 years commercially. I was working at, first telecom, then logistic industry, then I think banking, a car factory, and currently in a Polish software house, BGS Software, and indirectly, let's say, in a travel industry for a client. So the agenda of this talk will look more or less like an RPG party. Who of you likes role-playing games? There are some people. Okay, cool. So first, we'll look at things from, let's say, distant perspective to look what's going on in general. And then we will be looking from the perspective of three wizards from the Ivory Tower. So just a little bit theory to give you some insights and some basis. Then we'll get to business. So there will be this dwarf who is hacking orcs and goblins and doing the actual business job, what we get money from. And behind this dwarf, there is usually the cleric who is buffing him and healing him. And there we'll be talking about things that are kind of orthogonal to this business perspective, but nevertheless important. So let's begin. There was a guy in the marketing by the name of Simon Sinek, and he wrote a book, Start With Why. And indeed, when we are going on some kind of business or otherwise adventure, we need to think about three questions. Why are we doing something? What are we actually doing? And how to do this? So the most important question is why. So let's look into that. Why? The answer is, of course, simple: for money. So basically, how do we earn money on web applications? Usually in the past, there was some kind of front-end, business logic, probably a database. Users were clicking, doing some stuff they need to, and we earn on that. As time passes, needs of users grow, so they require additional features, and it didn't really make sense to do all those features in our system. For example, if you are, let's say, a travel company and you want to display a map, it's not the best idea to just jump into the car, start driving around the city and doing pictures of stuff so that people can see this on our website. It's a better idea to connect to some API, for example, Google Maps. So as time passes further, our system grew larger, more valuable, especially our data were more precious. So it's a good idea to open an additional revenue stream and create an external API so that someone else can connect to us, use our data, and pay us for that. So that's what we will be more or less talking about today. So an external web API. What is this? Well, it's kind of simple. It's just a set of endpoints with which we can talk using a specified set of messages, requests, and responses. And how to do this? Well, that will be the objective of the talk. But in general, there is an observation that although we are talking about talking to the machine, there are people behind those machines, so developers, programmers. And web API is kind of like graphical user interface to the programmer. It's like user interface to the programmer, similarly as graphical user interface is to regular people who just click stuff on the web. So there was a lot of things were said in the realm of how to design a good graphical user interface, and we can actually leverage some of that knowledge in designing web API. So the two important traits of people is, let's say, laziness and intuition. So we are all lazy, we want to do stuff as easy as possible and as fast as possible. And we have intuition, so we have some idea how stuff works, some standards, some experiences. And if we conform to that, well, it will be good for us in general. So that was a quick introduction. Then three wizards. So just a little bit of theory. Who recognizes Peter Morville? Nobody. Oh, there is one person. Cool. So it's a guy from design, basically, and he wrote an article 10 years ago or so, maybe even a bit more, where he pointed out the 6 important traits of good product design. So those traits are, in general, that product should be useful. So we should be able to do the business stuff that we want to do, the reason for which we bought the product in the first place. It should be usable, so it should be easy to do this. It should be intuitive. It should be desirable, so you are happy with the product. For example, if you are developers acting on an API, the API has a nice documentation and always works, and well, we desire this, let's say. It should be findable, so it should be easy to find the stuff that we want to do. For example, API is not buried under a lot of slashes and long URLs. It's somewhere close to the top domain of the company it owns. It should be accessible. Originally in the article, it was about the products used by people with some kind of disability, for example, let's say blind people. It's nice if the product then talks to them, or it's possible to touch the product and, for example, read Braille characters. In case of API, an example would be we are disabled because we are sitting behind a proxy that only only passes the GET requests, and we want to do a POST request or PUT request, and how to deal with that. I will be talking about this later. And it should be credible, meaning, well, every product should be credible. It shouldn't break, but if it breaks, the producer of the product shouldn't leave us alone with that. So in case of API, of course, sometimes stuff breaks. We get 500 from the server, but it's also nice if the API provider gives us more information about how to deal with this problem, and that would be another chapter in our story. The second wizard, Roy Fielding. Anyone familiar with Roy Fielding? Okay, there are some people. Anyone actually read the Fielding PhD dissertation? Okay. Oh, nice. So Roy Fielding, this is a guy who's involved in the, I'd say, standardization of HTTP and URI. And in 2000, he wrote a defended PhD dissertations where he defined the REST architecture. So basically, if someone asks you, what is actually REST? Because we heard this a lot of time, but if we think a bit deeper about what it is, so it's not a protocol, it's not technology, it's not really a standard, it's an architectural style. And it was basically the thesis is about properties, how we can assess web architectures. There are several web architectures in the assessment, and then there is this REST, so representational state transfer. And what's the idea? There are those 6 principles. First, client-server, so we have separately client and server. Originally, it was more of a front-end and back-end, but it's not really the case anymore. So we can develop them independently. We have statelessness, so basically each request has enough information to be processed without storing some kind of inside state, because if the machine dies, then we lose the state. We can send the request to another machine, and if we have everything with the request that we need to do, we are good. But there comes a problem. We need to send more data. So there is a principle of cacheability. So every response sent from the server basically tells us on what condition we can store it and reuse later. So then we can save a bit on bandwidth and computing power on both sides, basically. Layered system is about that we can, let's say, inject some kind of layer between client and server, and it should be basically transparent to the client. Uniform interfaces, more or less about that our addresses, our naming schemes should be consistent, and we should use HTTP semantics, so methods, status codes, and standard headers. And code of demand that's an optional requirement, but the idea is that we can, from the server, we can send some executable code that can be invoked by the client and thus extend its capabilities. So that's briefly about REST. Leonard Richardson, anyone? Yep. So just quickly, Leonard Richardson created, I think 10 years ago or so on the QCon talk, he defined the levels of how RESTful the architecture is, and this is the Richardson model you might have heard. And the idea is that, well, at the level 0, we have this swamp of plain old XML. So we have one endpoint to which we send an XML file, which basically says what has to be done. Then the level 2 is resources. So entities in our system have different endpoints. And if we have people, cars, groups, or whatever, they have separate endpoints, and we can work on that. The next level is usage of HTTP verbs. So no longer we have to wonder, Should I invoke delete cars or maybe remove cars? I don't know. We just go to cars and use the delete method. And the last level is hypermedia control, also known as HATEOAS, this beautiful acronym in our IT. So basically we add links to our responses that can lead us to related resources. Okay, those was a bit of theory. Now practice, so the business stuff. We talk about resources, naming, relations between resources, the behavior of particular HTTP methods, depending whether we have collection or single objects. About functions, because REST is about nouns, so how to deal with functions then. How to parameterize requests so that we can operate efficiently on collections, and how to handle status and, as it sometimes happens, errors. So quickly, resources, the centric focus point of REST. Nouns, plural form, so that we have cars, which is a collection of cars, and we can have cars/ID, which is a particular car. It's good to remember about not sharing technical details in URL. So for example, if you have Apache server, that's great, but do not put it in the URL. Just keep it clean and simple as possible. About naming. There was this ancient war between camel case and snake case. And actually now we have kind of a bit popular new style. Hyphen case, also known as kebab case, because you have like this piece of meat on a stick, then you have words with hyphens. And basically, the old war was between camels and snake. Camel people from JavaScript say, hey, we have JSON, we like JSON, so JSON is JavaScript, so camel case makes sense. On the other hand, snake case, well, they say, it's a bit more readable because words are a bit far apart from each other, looks better. Hyphen case, actually there's one problem with hyphen case, because if you run this through some automating frameworks that matches the name of property with the objects or the object itself, then you can run into the problem that there is a minus sign, basically, and that's an operator in programming language. So it looks cool in a content that is consumable by people, like you have a blog, you have a new article, there's a few words in the title, so your WordPress generates a nice link with hyphens in between, and it looks good, but in API, maybe not the best idea. Personally, I think I prefer camel case because I'm from Java, but yeah. Anyway, whichever you choose, just try to stay consistent, not like some standard libraries for some languages that mix cases. Not the best idea. So we have resources. Now we have relations between those resources. So how to model that? Basically, if the resources are independent, they can exist independently. For example, we have people and we have groups. Well, people can live without groups. Groups can, formally be without people. Then group membership is another resource. So basically, it can be created, deleted, or manipulated. On the other hand, if we have resource that depends on another, say we have a building and room in a building. If the building collapses, then the room is probably not too good either. In this case, we can model that in this hierarchy, that first there's building, an ID of the building, then there is rooms, and ID of the room. Behavior of HTTP methods. So what to do when we get HTTP verb, depending on whether that's a collection or object. So basically, with get, it's kind of simple. We just return the collection or the object. Of course, if the collection is big, we need to somehow limit that. With post, it's kind of tricky. If you post on a collection, that means, hey, there is an object, I want to put it in a collection. I don't know the ID of that, so just figure it out and let me know. If you do a post on an object, it used to be a partial modification of the object, but then we have this new method, not that new anymore, patch in HTTP, so it's basically no longer used, I think, in that context. With put, logic would dictate that if you put a collection, you just replace the existing collection, but it's, again, not usually the case we want. We probably want to just append the collection. It's good to mark it in documentation somehow. And if we do a put on a single object, we are replacing it. And here's the question what to do if the object doesn't exist yet. Well, we can allow to put new objects with a given ID. So doing put on an object which doesn't exist says, hey, there's an object, please put it under this ID I'm providing you. It's a bit tricky because if you let somebody outside of your system create IDs for your entities, you might be in trouble unless you have some kind of good validation or just allow this to be done from internal services. So you have to be careful with that. And delete, pretty simple. The entire collection, of course, that is risky, so it should be controlled in an appropriate manner. And deleting single item, this is the item. And like the newest method, patch on a collection, I think doesn't really make a lot of sense. But patch on a single object changes a small, say, part of it. Okay, we have behavior. Now let's move to functions. So we have this noun-centric system, and what to do if something appears to be a function. Well, first we can treat it as patching some other resource. For example, there is, let's say we bought a ticket for a train and now we want to cancel it. How to do this? Well, we can patch the state of the ticket and change its state to cancelled or something, but it might not be always the best idea. Sometimes invoking a function is kind of related with creating a resource. So we can here think, okay, I've created a cancellation object, which also can have some additional data to it. Otherwise, or if we don't have really good idea how to do this, we can just bend the rules, and if it makes sense, go with that. Don't be too dogmatic all the time. Okay, parameters. So just quickly reminder on how can you parameterize requests. We can put something in a path. It's not really exactly a parameter, because if we say cars/ID, it's not a parameter, it's just a name of this particular car. If we operate on collection, usually we go with query, so everything after the question mark. That is optional. If we want to separate ourselves from the, let's say, business surface of the API, we can go with headers or even deepen with custom headers. And sometimes it makes sense to send data just in the body of the request. One quick note. I encountered the idea that if you use some parameters that are kind of meta or platform related or very general, they might be named with underscore at the beginning, and it says be careful with that. So that's something that we can also use. So collections, searching in a collection. The simplest idea is just use equal operator. So you want people that are of age 27, so age equals 27, simple. What about if you want someone older or younger? Well, we can have operator for that. So for example, less than, greater than, then some kind of delimiter, and the value we are comparing against. We can combine the property we are comparing against with the operator in one single name. So if we are looking for an Arnold, we can use name like Swartger, for example. And okay, we found objects. So now how to look into those objects? Maybe we are interested only in a subset of fields, so we can list this subset of fields. On the other hand, maybe object has just one big field we are not yet interested in. Maybe there is an author with large biography and just few other short fields. Then we can just exclude some things. And we can define several styles of object, like small, medium, full, or something like that, and let users deal with that. So we found something. Now it's a good idea to sort what we found. So we can just specify one property by which we are sorting with some default order. We can add a prefix or suffix that determines the order of the sorting. Then we can list properties, then list properties that should be ascending and those that should be descending. Or we can just, for each property, we have a mirror property that selects a direction of the sort. Personally, I like this short version with just simple one character to determine the order of the sort. Next operation on collections, pagination. So normally we use offset and limit for that, or number of the page. But there is a problem if someone inserts something or deletes something while we are iterating on some parts of the collection. So we can define cursor that we just point to one item and work on that. It's not perfect, but it's somehow protects us from getting item twice or not at all in case of concurrent changes. There's something between pagination and sorting that is defining of some sort search parameter. For example, let's say we have ticket system. We can define that there is a page recently closed which has some kind of sorting in that, searching in that already. Another idea besides parameters is using headers if you want to again separate yourself from the business surface of the API. And it's always nice to include some links to the next page in the collection, previous page, last, or the first. Okay, status. So what happened with our request? Hopefully it was okay, but if not, we can do something with that. So first, HTTP codes. Generally, whatever happens on server, whether it was successful or not, it should return the status. The question is, how many statuses should I use? It's a difficult question. I believe in HTTP 1.1 there's around 70 statuses or so. Usually in APIs I found between 1 and 20. That's maybe the reasonable maximum. For example, Facebook always returns status 200, and then in the body of the response actually informs what happened, and so do National Railways of Switzerland, but they are not the best example of API design. Anyway, aside from that, I think that more or less 15 is the reasonable number of codes we should use there. What else? If something goes wrong, then it's a good idea to say exactly what happened. So first, some kind of enum that says which situation took place. It could be either some name like payment fraud or something that says something, or I found an idea of extending HTTP code, so we are adding an additional digit or two to HTTP code. Second thing, message. So just say what happened. For example, if your clients are developers from China or some other country, maybe then they don't like English very much, you can, for example, I can display this message in different language. Forgot the word. And the last but not least, what you can include in such objects is a link to some kind of FAQ or documentation chapter which explains exactly what happened. And again, don't expose internals, unless you are open source, of course, but returning stack traces in responses is not exactly a good idea, usually. So briefly on HTTP codes, 200, yay, success. 201 is used when we create an object. 202, when we start some kind of asynchronous processing, and the response is not ready, but we notify that, okay, we got the request, we are on it. 204, when we delete an object, then we return this. And when we return just a part of the response, and there will be more, 206. Okay, 300 redirections, kind of tricky. 300 is not that often used because there is no really a good standard on how to handle that. It says that there are multiple choices. 301, something was moved permanently, so don't try again on this address. 302, it's kind of deprecated because it was meant as 307, but instead implemented in the early days as 303. So what are those? 307, temporary direct, means the address changed temporarily, and please use the same method that you did before. So I do a post on the server, and if I get 307, it means redirect and use post again, I did nothing for you. On the other hand, 303 means go to another place, but use get to retrieve results. So basically, I got the request, I got some processing, and I have results for you, and they are somewhere else, but use get to retrieve that. 400, I think the most codes are in this category. Unauthorized really means unauthenticated. I don't know who you are. Forbidden means really unauthorized, but the name was already taken. It means I know who you are, but you can't do this. 404, yeah, we know that one. 405 means the object is there, but the method is not allowed because maybe it's immutable or for some other reasons. Conflict, well, the thing that you are trying to do in the request is in a conflict state with the server. So, for example, AWS S3 would return that if you try to delete a bucket that has still some files in it. That's a conflict in their definition. Gone means that there was a resource, but it is not anymore, and it's permanent situation. And 422, unprocessable entity, is basically kind of bad request, but on a higher level of abstraction. So you would return bad requests when the JSON is, for example, malformed. It lacks one parenthesis. But if you do a request to book a ticket and say arrival date is before the departure date, that's a good situation to return 422. So it says that there's a business situation and we can process it, although we understood the request. And server errors. So yeah, 500 generic error. We don't know what happened. We don't like that. 501 is kind of a way of saying that it's kind of under construction. It will be there. Try again maybe later, like in 2 weeks or something. But gateway and gateway timeout are somehow similar, and it's saying that when you're acting as a gateway, something bad happened with someone else. So either another service screwed the response or didn't respond at all. Sorry, there is nothing I could do. And it's okay if we are talking internal APIs and microservices, then we just go to another team and ask, hey, what's going on? But on the other hand, if I'm an external client, I don't really care which one service screw up something. I'm interested in what happened, basically. So it's not very recommended to use as status code in external API, I think. And service unavailable is a way of saying that, hey, we are down, but there is some maintenance, everything will be okay. Instead of just 500, it's not working. So that's the main, let's say, business part. Now let's go to this quickly to the supporting thing. So a few words about security, about versioning, cache and performance, throttling, HATEOAS, and then some less technical things, but also some miscellaneous. If you don't know where to put something, you can always put it in miscellaneous category. Security, well, 2019 we should use TSL whenever possible, and HTTPS. If someone goes to our endpoint without HTTPS, we shouldn't redirect them to HTTPS, just return error so the situation is clear. Cryptography is difficult, so even if you have PhD in cryptography and 10 years of experience, it's probably not the best idea to invent our own ciphers and cryptographic schemes, especially security by obscurity is a bad idea. Instead of passwords and username, it's good to use API keys as they are more secure. It's difficult to guess them, let's say. And there is probably everyone, or almost everyone knows the OWSAP, Open Application Security Project, but if you don't, just check this out, .org. It's a list of 10 most important threats in web application, and it's always good to see what is currently on top there. Okay, versioning. So our API changes and how to deal with that. The most popular and usual solution is just to embed version in the URL. So we say v2 is API version 2. v1 or without anything is version 1. On the other hand, we can go a bit deeper and use parameter for that. So that way, for example, if someone does not include this parameter, so it is optional, we can assume that we are returning the newest version of the API. Again, if we want to go away from the business surface of the API, we can use headers, either accept header for that, or we can use our own headers. And API versioning and resource versioning are two different things, so we can have new API, old API, and return new version of resource and old version of resource. Those shouldn't be confused. Cache control. Cache is difficult. But in general, what we can do about this? We have this values of cache control headers. Basically, public and private is about whether the information is meant for just single users or is publicly available. So if there is a logo of the web page, it can be marked as public. If there is some particular data for the user, it probably should be private. Those should be public and this should be private. If you can allow resource to be stale, we don't care about it to be very fresh, then we specify some kind of max age, so how stale it should be. No cache doesn't really mean that we don't have any benefits from caching. It just means that the resource should be always fresh. So whatever the client checks for the resource in proxy, we need to check on the server. And if the resource didn't change, well, we are in luck. We can just return the value from the proxy. If not, we need to refresh that. On the other hand, no store says that we can't use caching at all. Basically, it's about sensitive data like medical records or anything related with money usually. And we don't want to store even on the device of the user, or maybe especially on the device of the user. So how to deal with all those values? There are actually like 15 or so more. Basically, we need to think if the data is private or public, if it can be stale or not, and if it is sensitive. And then we can set some effective caching strategy so that we save both on bandwidth and performance and computing power of our systems and clients. Throttling. So how to deal with many requests. Basically, you can just return 500 server kaput. But we can do better. For example, there are 3 headers, not standard but commonly used, that say that there's a limit in time window, how many requests are left in current time window, and when the new time window starts. And if the client is in no luck and there is no more requests in the time window, then you can return 429 too many requests, and the information that, let's say, hey, there will be new window opening in 7 seconds, so just try again then, and not try every second because it won't work anyway. And again, we save both on our side and the client side. HATEOAS. Who of you did play Diablo 2? Yeah, lots of guys. So it's Lord of Hate, Mephisto. It kind of went well with the slide. HATEOAS, so hypermedia as the engine of application state, the most beautiful acronym in our industry. The idea is that with the response, we return links to related resources and what we can do about this resource, around this resource. So that way, a client doesn't have to remember all those links and follow the versioning. He can just take the link that we return and follow that. And there are several, there's no really one standard of how to do this. There are several. Personally, I used Hall. It worked pretty well for me. There is also collection plus JSON, which is kind of originating in collections, but works pretty well with links too. There is JSON link document, which is kind of good if you don't want to break backward compatibility. So like encapsulate the request in other objects. And there is Siren, which is, I think, quite powerful, but not that popular. Documentation. So moving a bit away from the technical side. Documentation should be easy to find and ideally public, so I don't have to mail the support and wait 2 weeks to get the documentation. There are 3 tiers of kinds of documentation. There is like this address book, which is exhaustive reference. Everything we can do with the API, but really boring. Then there is engaging tutorial, which is kind of a business story. We start with something, we do some other requests, we complete something, and we can follow that. And there is an engaging, that was engaging tutorial. There's concept quick start. There's something that we put on the front page of our product, so the developer can just take it and start from that and move efficiently. Miscellanea. So as I said about those 6 principles of good product design and people with disabilities. So if I'm a person with disability and I can't do a post request because of my proxy, then I can use a header for that, HTTP method override, and just specify the value of the method I really want to use while I'm using get method. It's kind of maybe obsolete because most modern web browsers do this, but we can add a parameter to pretty print JSON, so automatically insert indentation and new lines, so it's more readable. In browsers that do not support this. For encoding, we have standard header, so let's not invent our own solutions. Resource UID. When we are creating new resources, it's not the best idea to just go with consecutive numbers, 1, 2, 3, and 4, because then somebody can just ask for all the numbers and get all the data from our database. And aside from losing data, we are losing quite a lot of performance here. So it's good to use some longer and random IDs, so it's difficult to guess them. And somewhat similar, request UIDs, sometimes called correlation IDs. If you start let's say, the processing flow on the boundary of our system. Then some calls are fired to microservices. Maybe there are quite a lot of them. We can add a parameter with this ID of the request, and then it's easy to find this in logs and debug the situation. Yeah, REST clients and browsers. There are some API vendors who have an idea that if somebody accesses API from web browser, it means we want to return HTML instead of JSON. It's generally a bad idea. We have content negotiation for that. We have standard for time, so let's not invent our own standard for that. Health endpoints. It's more about internal APIs, not external. But aside from the health endpoint that we need for example, our Kubernetes or some other automation to see if our service is okay, so it's a good idea to add more information for developer. For example, the Git version from which the service was built, or the values of some important properties, or some other stuff. So it can be a bit enriched. And last but not least, external APIs. There are often project in the company which has this B2C, business to client model, and mainly front end, to add an external API and connect with big business. And it usually sounds quite good and easy. We just make some kind of gateway, separate service, do some configuration, add security, a few other things. It will be nice. But in practice, it turns out that those projects are actually just a bit about new technology, and in quite large part in dealing with existing problems in our systems. Meaning, if you want to create external API, we have to think what should be exposed in that, because often in internal APIs we expose a lot of things that are not very secure to expose. So now we have to limit that. Often there is a situation where a business flow of your system is not really prepared for B2B. For example, you have flows to pay with credit cards or Braintree, PayPal, or whatever, but you don't have an option to issue an invoice, and you have to add that to make it work. Or on the other hand, it's often common that you have to do a little small modifications in many parts of the system. For example, remember last time when I was taking part in a similar project, I think it was the moment when I checked out the largest number of Git repositories in this company, because we had to add a small field partner ID in very many places. So when you hear that there is an external API under construction, beware, it might mean that there is a lot of dirty work to be done, but on the other hand, that's an opportunity to get to know the system better, because you work on many places and get this good overview, so how the client would see it from the outside. And yeah, another aspect is that often there is no good consensus of the naming of part of the system. For example, when we did this API for travel, it turns out that one microservice returns something by the name of segment, another service calls this itinerary, another service calls this leg, and now we suddenly have to somehow unify that, and it should make sense from the business point of view. To sum up, good API takes a lot of effort. There are a lot of things we need to think about, especially some of them are not that visible from the business side. API is first, it's a product for developers. Thinking as a developer might be kind of tricky for business people, but API to developer is more or like graphical user interface is to regular user. So we need to keep that in mind. If you are going with REST, because it's not the only way, for example, you can choose GraphQL. Yesterday there was a nice talk about GraphQL. Did anyone attend, maybe? Yeah. So there are many alternatives. There are binary protocols, but if you are talking about REST, verbs are the center of REST. We need to take advantage of HTTP semantics, so methods, headers, status, all that good stuff. And look at those principles, but do not follow it blindly, because sometimes something doesn't really fit into the picture, but doesn't fit into the REST picture, but still makes sense, and we can just bend the rules if we know what we are doing. Okay, if you fall asleep or just come later to this lecture, most of what I said and quite a lot more is in, I think, 6 or 7 currently articles on my blog. It's how to train your Java, just like the movie, but with Java instead of Dragon. So you're welcome to drop by. Okay, questions? Yes? Which exactly headers?
Throttling headers like too many requests or something which controls the throttling.
I'm not sure actually, but I think this is one of the common functionalities that is actually implemented by API management platforms like APG or however it is now called, because it was bought by Google, WSO2 or AWS Gateway. I think in all of them I saw the point about throttling, so I suppose they do. Any other questions? Yeah.
You didn't mention anything about parameters inside the body that we are using it, that we are actually picking in external API. I'm often seeing that people use a trait to use request response as a part of naming, and for me it's not good because it should be resource and should be oriented to resource, not event. What do you think about it?
Well, I saw the problem that somebody needed to request a long list of the question basically about parameters in request body, if they are good or not. The problem was that somebody has a situation that he wanted to request a very, very, very long list of resources. And the list was particularly that long that it may not fit the length of the URL. And he was wondering that maybe then it is a good idea to put it in a body.
No, actually, I mean, when I'm looking for a Swagger API, yes, I'm often seeing the description of posts that people describing elements, yes, as for example, peoples, yes, and they called the request people request and define the body, and response people response, and define the body of response. So it's not looking like resource-oriented style, but very often I see this style of defining documentation, and I didn't find any good place that describing how this API should like and how we should describe this request and response.
I'm not really sure how to answer that. I don't know, gotta think about it. Any other questions? I don't want to stand between you and beer for too long, so maybe if there are other questions, just catch me later, today or tomorrow, and that would be all. Thank you.